Great. Hello, everyone. Thank you for joining. And I would like to thank IIRSM for having me, for hosting me. Today's topic will be about lifting plans and to understand who lifting plans really are for. Is it for the lifting engineer? Is it for the supervisor? Is it for the safety officer? Who knows? I hope that by the end of the presentation, you will have a better understanding of what the purpose of lift plans are for and what we can do to improve them. So first, I'll start by introducing myself. My name is Kamal Kassab. I'm a lifting engineer since 25 years now. A few years ago, I started my own company because I felt that lift planning is such a diverse field that it deserves and merits a specialized company that would serve others to help them reach their targets through the lift planning process. A brief introduction about my company, Ant Dynamics. So the name is obviously influenced from the way ants work. Ants, as you know, they can lift the weights above themselves, and the way they work together is also very good, and there's a lot of communication between them. All these lead to very efficient dynamics of them harvesting or taking their food, storing it, and building their tunnels and what have you. So the mission of the company is to offer consultation services to clients and focus on providing the cost-effective, the best effective solutions for lifting operations. It's not a lot of contractors just take the easy road. They have a lift, they just go for the biggest crane available. However, that is not very cost-effective and it's not always the best approach. We do a lot of lift plans for single crane lifts. Multi-crane lifts we do. We also do alternative lifts. For example, in this case, we're a skidding operation of an equipment going underneath a existing precast foundation. Also, we provide the services for bull rigging. Yes, I know for many people it's an everyday, very easy to do. However, in some cases, when you have a large spool going underneath a pipe rack, it's not so easy. And the client usually has the right and does, in fact, ask questions about what are you going to do to bring this piece of spool inside my pipe rack. Also, by using specialized software related to lift planning, we can export to 3D models, like here. And also, I will show at the end of the presentation a recently additional feature, which is now becoming more and more prevalent, which is to leverage the reality capture, such as drone mapping, into lifting plans. Why Ant Dynamics? Well, to be fair, I think it's safe to say we are competent engineers to take care of this specialty field. Not every contractor understands or has the ability to deliver projects on time, and a lot of the hiccups, especially at the start of the project, are due to insufficient or due to issues with lift planning and the lifting plan, and how to convince the client that you really know what you're doing and that your plan is sound and safe. Expert engineering, certified planning. Yes, obviously lifting plans have to be endorsed, done by LEA endorsed appointed person, which is the case. Also, I've taken a lot of certificates with LEA. And also I attend a lot of conferences related to LEA, related to lifting. So I'm always up to date with the latest trends. For example, Specialized Carriers and Rigging Association, I travel every year to this conference, to the workshops, to understand what's happening and what have you. Also, as the agent of Cranimax in this Middle East region, we are always up to date with the latest innovations in software and how to leverage software to improve the lifting plans. I will start also now. I will go ahead with the presentation itself. Are you able to see the presentation?
Yes.
and a multi-stakeholder approach to lift planning development. Can you see that?
Oh, yes, we can see that.
Very good, very good. So let's get started with this very interesting presentation and why I want to try to challenge or to make other people understand that lifting plans are not just for lifting engineers or the safety officers or the safety supervisor or the rigging supervisor. There are different levels of lifting plans, and we have to understand which lifting plan is meant for whom. So let's get started, and I hope you enjoy. The role of lifting plans. Lifting plans are essential for safe lifting. This everybody knows. I think that it's an opportunity to analyze the risks, collect the data, to basically plan the lift. So as an analogy, if you are going on a flight and the captain doesn't have a flight plan, would it be safe to fly? Would you feel safe flying the plane? Wouldn't the captain want to know what is the weather like, if there's fog in the other city, the wind speed, the weather conditions? They have to check the fuel, they have to check the luggage, the weights, all of that is the flight plan. Similarly, when you want to do a lifting operation, it is always good to have a plan to know what you're going to lift, what is the weight, what is the path you're going to go through, has the ground been checked. This is routine, but do we really understand this? Lifting plan has a purpose. It's not just mandatory because client says so. Because if something does go wrong during lifting, then you are in trouble. Then gravity will say, "Wait a minute, we're gonna let this thing fall over," and then chaos will happen, and whatever's being trying to save pennies for by choosing to do something without a proper lifting plan or without the proper assessments is very costly. So that's why it's always good to have lifting plans, and that's why a lot of clients rightly demand that their contractors show them a lifting plan to demonstrate that they know what they're doing. There are a lot of requirements, industry standards. Some of them are by procedure, some of them are standards. So as an example, international standards, I can think of the ASME 30.1, which personally is my favorite because it talks a lot about lifting plan in details, and it talks a lot about how to calculate and how to reach the right conclusions. BS 7121 obviously is another good standard. However, I do feel that more work has to be done to talk about the lifting plan drawings as a whole. Where I work, which is in Qatar, a lot of lifting plans and procedures are found in the company procedures, which are the plants that actually allow or have work within their plants. So, for example, there is the Qatar Energy lifting procedure called Corporate Lifting Equipment Regulation. There is the Qatar Energy LNG Code of Practice for Lifting. There is also the new, recently added, very detailed major project lifting Code of Practice procedure, which I am now working on. It is basically the same as, very similar to the PRC 013. However, it does differ in the details. And for anyone taking up a project with Qatar Energy, LNG, I would definitely recommend that you read this 015, PRC 015, because if you don't understand it very well, you'll be in for a lot of surprises. So it's good to know before you get started. Then there is the GTL project, which is also one of my favorite procedures because it's very well written and covers every aspect, almost every aspect of lift planning. There are other lifting procedures, and these are in other countries in the Gulf region, such as ADNOC. And there's obviously the Saudi Aramco lifting instruction manual. It talks about various things, and I know that it's being continuously updated. The reason I mention these procedures because I know that a lot of the audience are working in the Gulf region. So for our audience, actually, it is more relevant to talk about the lifting procedure per project than to talk about the international standards, such as the ASME, the BS standard, as well as others. Having gone through or having worked with different procedures and standards, I have noticed the following. A lot of the standards, or most of them, they talk about the workflow, they talk about the roles and responsibilities, they talk about the QA, QC, they talk about a lot of documentation and certification. So for example, this is the ASME P30.1 2024, which has been recently updated. So this 2024 is a new issue. It's been almost around for about a year now, a little bit more. So they talk about how to categorize lifting plans and the role and duties of everyone involved. The nice thing about it is that they talk in depth about ground bearing pressure and ground bearing capacities and how to do the test, not just what the values are. So it's a very practical standard, or best practice standard. It is not compulsory, but it is a very good guide for that. And they also talk about lifting plans as a drawing, the bare minimum information that is needed to be there. Here's an example of the workflow from the Qatar Energy LNG PRC 015. As you can see, they talk a lot about the flow of approval cycle. And if I can go into more details, I'll talk about the conditions for categorizing lifting plans, whether it is routine lift, non-routine lift, critical lift, or about the certification required, the NDT reports about the PADIs. However, despite reading over almost 100 pages of this procedure, I till today do not see really a clear-cut understanding of what a lifting plan must entail. So you see a lot of people talking about lifting plans, but everybody understands lifting plan differently. So a planning engineer would think of lifting plan one way, whereas the site engineer would look for other stuff, and the crane rental company would be more interested in other things. And hopefully by the end of this presentation, it will be clear to everyone what everybody should see and what is the amount of detail that should be given per lifting plan. So this is what I just mentioned. They do not focus on the specific requirement of the lifting plan drawings. And the lifting plan drawing is the jewel of the lifting plan package. So for example, if I have to lift a compressor, I don't just give my client a drawing showing the crane position and the compressor and how I'm lifting. No, I have to give them a package which would contain method statement, which would contain certificates, which would contain a cover sheet, certificates of the slings, of the rigging, the shackles, the crane certificates, the load chart, all of that, the crane operator, all of that. However, it is impossible to do a package without the drawing. So the drawing is the jewel of the lifting plan package. So here again are the parts of the package, some of the parts of the package. Of course, every client may request more information. However, all of them will look for this part which I highlighted, which is the lifting plan drawing, and this will be the focus of this presentation. So there is a myth. A lifting plan is a safety requirement only. That's the myth. Actually, no. Lifting plan, there are many stakeholders involved in lifting operations. Even those who are not on the field directly, are being affected every day by the lifting operation. So it's important to always identify the key stakeholders. I'll mention some of them. So you have the lift directors. In this case, it could be the lifting superintendent, the lifting engineer, appointed person, the crane owner, the crane operator, the riggers, the construction managers. Of course, construction managers are affected because they have to deliver on time and in a meaningful way. The planning engineer, the cost engineer, the crane rental service, the crane rental company, all of these are affected by a lifting operation, even if they are not standing next to the crane during the lift, but it is affecting. Also, you have, I can mention more. There could be also like, let's say you are in a neighborhood. Like now, I am living in next to my house. There's a crane next to a hotel that I'm living next to, and this crane has blocked the road. So all the people involved, all the people in the area, have to now do a detour, which is part of the reason I just arrived. We have to do a detour now to arrive to our home. So what used to take me like 5 minutes to arrive now takes me around 20 minutes, for example. So cranes are huge pieces of equipment, and they can have they will always have an effect whenever they are working. They will always influence other areas, even those people not involved in lifting. Developing a lifting plan. A lot of people who work, or a lot of companies who work in lifting, have this mistaken assumption that the lifting plan is one goal. So you give the drawing to one person, and this person is expected to develop the plan. Okay, I have a foundation to lift. No problem. Give it to the lifting engineer. He will make it. No, and no. Lifting plans are the result of an iterative cycle. A lot of communication, a lot of back and forth has to go on. So the first part is to gather the information. Gathering information means knowing what is in the surrounding, getting the weight of the item you're going to lift, understanding the limitations in the area. Then the person doing the lifting plan, which I would call the supplier in this case, has to provide a rough sketch. Okay, I plan to put my crane in this location, gets feedback, a lot of feedback, and this is an iterative part. Then submit the detailed drawing, and again wait for comments, maybe from the main contractor, maybe from the client, maybe from the main stakeholder. So it is important to remember that lifting plans are not done in one step. They are the result of an iterative cycle, in some cases many iterative cycles, and a lot of discussions. So it's important to think of lifting plans not only as engineered drawings or detailed drawings, but also as a communication plan. You are using lifting plans to communicate to the others what you're really trying to do. And the clearer the plan, the better it is for everyone. So I will talk a little bit about the limitations of the conventional way, what I see a lot of them. So a lot of people, what they do, they have a draftsman. This draftsman has to do the drawing, takes the feedback from the supervisor, and back and forth. The problem is with this method is that the draftsman is not able to see, or you cannot expect that the person making the drawing to know all the givens, all the data that will affect the drawing, that will affect the lift. So, for example, the conventional way is to have I repeat, the conventional way is to have a draftsman taking instructions from an engineer or from a supervisor and do the drawing. So the draftsman has to do like at least 50% of the work and the decision making, and such as selecting the crane, selecting the crane configuration, and then the person who is in charge would have to review that drawing. There are many ways that could go wrong here, which I see, which is, for example, this is a laborious, this takes a lot of time. It's a laborious effort. There isn't too much time for iterations. So you'd have to wait until the final drawing is ready. So I have to wait for the draftsman to finish drawing the crane, the sling, put the slings, put the shackles, put everything, all the details, in one go. And then I will start to comment on the drawing. And this is a very inefficient way, which I do not recommend. However, it is the most common way that is happening, and it is still happening. So I have another proposal, which when I quote to other companies, this is the process that I would prefer. Like other digital construction, like building information modeling, there is something called level of detail. And what this allows is better planning, more focus on planning, and then to develop the details as the project goes on. It is easier for someone like me to develop a high-level lifting plan rather than to go and focus on the nuts and bolts of the detailed lifting plan. And this would allow us, so it's easier for me, for example, to develop many lifting plans at a very high level for the same project, all right? And I call this level 1. At this stage, I would choose the crane type and the location. So if someone tells me I have a compressor to lift, we know that the crane has to be located in a certain area. And I would say, yeah, I need a mobile crane, or I need a hydraulic crane, or I need a crawler crane in this case. And then we can sit and focus on the exact size and stuff. Then as the project here, I'm putting 6 months before. This is the ideal case. 3 months before the lift, By that time, you should have decided on the crane type, the size, and the location, which means that I need an all-terrain crane, I need a 250-ton all-terrain crane, and I need it to be in a certain location. 2 months before the lift, okay, to be in good shape. Now, some of you might disagree, but this is what I see from my perspective. You should at least have selected the crane model, the counterweight, and the configuration. Configuration being the boom length, the counterweight, the outriggers, how big they are. If you have steel mats, wooden mats, you're gonna be using, all this should be known 2 months before the lift takes place. And this method also encourages a lot of planning and a lot of communication. 1 month before the lift, I would say level of detail 4, which means I know the crane model number, the crane model, the exact configuration, the counterweight, the ground bending pressure, the exact rigging accessories I'm going to use, which means the slings, the shackles, the spreader beam, parts of line if I need, and whatever more documents that you're going to use to submit. So this is about the lifting plan drawing level of details. And I would like, I don't see this being followed, but I think that if every company follows this approach, you would end up with less revisions, better control over your lifting plan, better management of your lifting plan, and avoiding mishaps. So for example, if I'm putting the crane in a place which is gonna fall on foundations, you know, if I tell my civil engineer 6 months in advance, then the civil engineer might say, you know, okay, I can keep these items on hold, I can put them later. However, if I come 1 month before the lifting gonna take place, and I tell them, hey, those foundations you put up there, please remove them. That's not gonna work. You know, you're gonna end up getting. He's probably gonna say no because it's gonna cost them a lot of money. Maybe they've already put structures on these foundations. Maybe they've installed pipes on these foundations. So they tell you, well, you know what? Go find another location. So you'd have to go and rent a bigger crane to be farther away. So what this does means if you keep waiting to the last minute to give that one lifting plan drawing in detail, you will probably end up, you know, the contractor may find themselves ending up paying more frustration, more delays, just not the efficient way of saving money. So a little discussions about what each one, I will just go briefly through these. I just had to write everything down just to keep my, let's say this presentation detailed enough. However, I'll skim through this in detail. So level of detail 2, yeah, you'd have to know the crane size and the beneficiaries of this, the crane owners, the construction managers. So let's say I want to hire a crane. Yeah, you would tell your procurement or your subcontracts department, please start looking for a crane in the market. I need it after 3 or 4 months. That will give your guys a lot of time, enough time to go and make their inquiries and select the best price rather than to wait for the last minute and rush to get a crane. Phase 2, the detailed lifting plan level 3. So by this time, you know which crane you want to get. Again, you have more details, more information, and you start honing in on the planning stage. Phase 3, which is to actually execute the work. Basically, by this stage, all the details are there. By now, you are executing the work. It is too late by this stage. So if you're going to do a lift after, let's say, 2 weeks, and you haven't decided on the crane size, you haven't decided on the slings and shackles you're going to use, then I would say you are already in trouble because it's too late to make any big decisions that may facilitate your lift. Beneficiaries of all of these are the lifting managers, site managers, the lift directors, and really this is a way of understanding that you have an overall approach when you think of lifting plans, is that keep in mind that there's many people, many stakeholders involved. The approach would change. So let's start here by talking a little bit, showing you some examples of lifting plan drawings, level of details. Here I would say the definition of a lifting plan drawing. It's an A3 size scaled drawing. And I say scaled, it has to be scaled because without scaling your drawings, you know, you won't be able to determine the clashes properly. So anyone who sends, you know, sometimes I see people trying to get away with sketches, like drawing a box here and, you know, lines and arrows and whatever. Yeah, that's a schematic. I mean, that's not a real lifting plan drawing, and that's not really gonna give anyone clear idea of what's going on. And chances are, if you take this drawing piece of paper and go to the site and try to apply and execute your lifting, you're gonna be asking your supervisor, lifting supervisor, to start to improvise, to come up with solution while they're standing on their feet, under pressure. So you're really in this case, you are transferring the responsibility of the lifting engineer, or the party that's supposed to provide the lifting plan, is transferring their responsibility really onto the lifting supervisor. And in some cases, the lifting supervisor will transfer this responsibility onto the crane operator. And we have, so you say, okay, I have the permit, but the permit doesn't match the reality. So what happens is you're really asking your crane operator or your lifting supervisor to come up with a solution. And if the necessary tools are not there, like he doesn't have the right crane, the right shackles, the right slings, they're gonna have to come up with a solution to keep the job going, and things will not go as planned, and this is why things start to go wrong. So yes, maybe they can do a lift, like maybe they do 20 lifts without any problem. Maybe, you know, as long as nobody hears of an issue or the crane doesn't topple, you think, yeah, okay, Mr. X can, you know, he's got the experience, he can take care of it. At some point, your luck's going to run out. So it's always good to have this procedure in place, to have a lifting plan in place, to make sure that this does not happen, that every drawing that arrives is clear enough for them to follow. And believe me, the lifting supervisors, they would, whether they say it or not, they would always like to see a very clear lifting plan and with good quality. It makes their life so much easier and takes off a lot of their pressure. Personally, when I do my lifting plans, I don't just do it to get the approvals. I do it because I think about the end user, the riggers, the rigging supervisor. I want to make sure that there's nothing in doubt, and if they see the drawing, they would come back with meaningful comments to make changes in case there are any. So it's important to have your lifting plan drawing to be clear as possible and to be submitted or shared as early as possible. Here's an example of a level 1 detail lifting. So this is like 1 year before the job. All right, this was given to me a year before. This job hasn't even started. So the project manager was wise enough to say, look, I want a very detailed, not too detailed, but enough information to plan my crane setup, where it's going to be loaded. So here you can see the crane, you can see the type of the crane, the size of the crane. And this is mainly for the project manager, project engineer, the planning engineers. This is even before the supervisor, the rigging team comes to site even. This is before they even mobilize the site. Then you have the level of detail 2. So in this case, you have the crane location, the dimensions of the load, the minimum and maximum radius, the crane type, the boom length, the configuration. So you have a little more details than what you just saw earlier. A level of detail 3, a little more details than level of detail 2. So here you have, for example, contingency factors, the location where you're going to pick up, you know. So this would really help the planning team. And at this stage, for example, the procurement would have enough information to go and search for the crane in the market. So you have the boom length, you have all the ground bearing pressures, so your civil team can go and check if the ground is good enough or not. Percentage of the crane safe working load, so you know that this is going to comply with your client's requirements or not. And it's enough information, I would say, for proper, let's say, coordination with all other disciplines. So this is an example of a level 2, level 3, I would say. So you have all the information you need, the crane model, all the details, excuse me, are here in this little box here. And this is very good for planning engineers, crane owners, construction managers, host controllers. This is all they need. This is not for the permit. This is just for coordination and to make sure that the project is going to run smoothly. So this would be available, let's say, 2 months before the lifting takes place. Now for the full level of details, and this would vary, I would say, depending on the project and depending on the client. So if you're working with Qatar Energy, they would make some requests. If you're working in a brownfield area, the client would have another set of requests. If you're working with Qatar Energy LNG, for example, if you're working with British Petroleum, they would have another set of rules. Shell have another set of rules. So at this stage, level 4 detail, it is very important that you understand your client's requirements. And I have to say this again, it is very important before you start even mobilizing your cranes to know what requirements does your client need to see, to be convinced, to feel that they are confident that you can do the lift. And from this level of 4 detail, and sometimes I would say level of 5 detail, you use this drawing to start preparing your package to get the permit to go ahead and do the lift. So I'm not going to go through all the details here, but it's just important to say at this stage, you should be able to point out the potential clashes with existing obstacles. For example, if there's a tree in the way, if there's a light post in the way, if there's a structure in the way, all of this should be highlighted. Actually, all of this should be highlighted in level 3 even. The exact location of the center of gravity, orientation of the item. Yes, sometimes some rigging teams, they install a vessel, let's say, in the wrong orientation, and then they would have to come back and lift it out, reorient it, put it back in. That's that's a lot of inefficiency, I would say. Crane configuration, capacity of the hook block, the detail of the hook block, the mat size, the coordinates, the spreader beam, so you can go and find the certificate for the spreader beam and then get the NDT and all the MPI tests if you want to check the weld of the spreader beam, inspect the spreader beam, all of these details. So all the details which are enough for the rigging team to execute should be in this level of detail 4. So this now we've gone from the high level project management, cost control to the execution level. This is an example. This is my drawing, but other companies also have very detailed lifting plans. So as you can see here, you see the exact location of the crane, the mat sizes on the drawing, the clearances, the boom angle. Some clients, they want to see the boom angle. And here also a detail of the rigging arrangement. So it has to be very clear for everyone to see, for the rigging supervisor, the crane operator, and all those involved. And here also you have a description of the exact rigging tackles, so they can go and check if they're available or not. It's important. It's a good practice to have a list of the rigging gear that you're going to use. This would make it very easy for your material person or the storekeeper to get themselves ready and prepare the stuff you need to do the lift. The last thing you want to do is to start searching for equipment and rigging accessories right on the day of the lift, which is guaranteed will result in delays. So here's an example of a lifting plan, level of detail 1. So you just have the crane and the location. Crane location, level of detail 2. So this table starts to fill up. So you have the coordinates, you have the crane type, you have the crane size. No detailed crane model, and you have a basic, a rough estimate of what percentage of the crane capacity you would be using. You go to level of detail 3, so you can see now I've specified the pickup point. So this assembly location where I'm going to pick up the load from. Maybe there's another party in the project who wants to use this area. So it's important that this is shared with everyone. And if you can put it even on the 3D model itself, would be good because everybody can see it. There is here I've added also, you can see the crane model, specific crane model. So your procurement can go and select this, look for this type or equivalent, the counterweight exactly, how much. Contingency factors, this data has to be filled up. So here the stakeholders are basically the project managers, the crane owners, the cost controllers, and other disciplines who might be affected by this. So, for example, if a civil engineer wants to dig up a hole in this area, they come and tell you, hey, please, can you put your pipe somewhere else? Can you assemble it somewhere else? At least give them the chance to tell you this before they come and dig up the area, and then you find that, oh no, I cannot use I cannot pick from here. I have to shift my crane a little bit back, or it's just stuff that does happen. Here's the level of detail of 4. So by this stage, all the information, all the data have been filled up. My client wants to see the matting arrangement. My client wants to see the height, the boom tip height, the clearance from the building. Yeah, this is really the stuff you need to present to get the permit and to get the go ahead to go and lift. So everybody here is probably involved in this case, but what you see here is that what you didn't see before, that the riggers are now involved, the crane operator is involved, permit issuer is involved. So you have so many stakeholders here. And by stakeholders, I mean all those who are actually going to be affected or involved in the lifting operation. So here, everybody's involved. Sometimes the client may want to see more, more information. For example, they want to see to mention the tension load on the slings, because some clients, they want to make sure that you're not using the slings at beyond 75% of its capacity, for example. So you have to show all of that. So again, depending on your client's needs, it's always important to check with your client first before you go and submit to them a drawing, because every client, it's a very subjective, let's say this is a very subjective field. So it's until so far we don't have in this industry black and white requirements for it, what can qualify as a lifting plan. So that's why I would recommend always sit down with your client, consult with them, and see what is acceptable for them or not. Get their word, and then submit to them based on what is agreed. Don't agree on one thing and then send them something that's short of what they asked for, because it's not very nice feeling. And the most important thing about lift planning is, like I said, communication and building trust with your client. Now, I'll mention this level of detail 5, and this is something you would find more or less in the brownfield work, which is actually when the client starts to ask for engineered calculations on the rigging, on the slings. Not very common, but is requested sometimes. I know it is not only requested, it is mandatory when you work offshore. And you have a lot of offshore mines coming to onshore, and they have every right to say, hey, the same level of control I used to have in the offshore environment, I want it on onshore. That's what makes me feel comfortable. So yes, it is sometimes requested that you do even more detailed calculations in this fashion to convince your client of these calculations, that the slings are being used correctly, that your shackle is not overloaded, for example. At this stage, really, this is not going to affect really the planning engineer and the project manager, but it's important for them to understand that there's a lot of work that goes into these highly detailed lifting plan drawings. So maybe the project manager would see, wait a minute, when we started the project and we were getting these lifting plan drawings, and they didn't understand, to them, that's a lifting plan drawing, like level of detail 1. But now they're seeing that the lifting plan drawing is requiring 3 days, 4 days maybe, and they're confused. Why is this happening? Well, the reason is that now there's more work to be done. There's more calculations. There's more, checks to be performed. So they would think maybe at the stage of execution, I might need, for example, 3 lifting engineers or 3 lift planners or 5 draftsmen instead of 1 or 2, which I started with. So this would help the guys really understand to expect to do their manpower, to plan their manpower accordingly. And it's important for them to understand also the management level, that once you reach execution stage, which is when you actually start doing the lift, it is very difficult to do the planning that you should have done 6 months earlier. And what that will result in, more panic decision, more rush decision, panic buys. Panic buy or panic renting means you're going to be renting whatever's out there in the market, good price or bad price. You're going to take whatever's available. So you're ending up paying more money than what you could have saved earlier on. So I've done a draw, in my assessment, this is basically what's really needed to do a lifting plan, level 4 detail lifting plan. So you need an elevation view, a side view, a crane footprint, and a table. Orientation, plant orientation, and as a bonus, I basically provide a isometric view because, in my opinion, it makes everything clear for everyone to read. And it's always, we are human beings and we are used to looking at things in a 3D environment. So I'm a big fan of 3D lifting plans. Other people are not, but just giving you my opinion. The clearer the plan, the better the execution, and the better the feedback even. Also here, it's also important to show the list of rigging accessories that are going to be used. Always include this. And if you make it as a table, it is always clearer than to show like arrows pointing to a sling or a shackle, and just putting the bare minimum just to get the approval from your client. In my view, like I said, in my view, when you're doing a lifting plan, you should always have the end user in mind, not just the guy who's going to approve your lifting plan drawing, because that's no good. I mean, you want your lift to be done properly. So properly, clearly, and without pressure. The clearer the more hours you put on your lifting plan drawing, the clearer you make it, the faster the execution will go. And in my view, in my drawings, I don't have a problem in making my drawings, 3 pages, 4 sheets, 5 sheets, regardless. The more sheets is not, there's nothing that says that you are limited to 2 sheets maximum on a lifting plan drawing. And I see a lot of contractors try to squeeze in all the information in one drawing, and it ends up looking like very difficult to read. So take your time, be kind, be generous with your drawings. We're not always printing these drawings, these lifting plans. So a lot of it is reviewed on PDF. So yeah, so don't worry about making your plan clear. Just do whatever is important for everybody to understand what you're doing. Ground bearing pressures. I do see a lot of rules of thumb being used, and I do see a lot of formulas being invented, Excel sheets, sometimes wrongly by the client, I have to say. The right way to get ground bearing pressure is to get it from the manufacturer. All right. Calculating ground bearing pressure is a laborious task. It requires the user to know the weight of each part of the crane and to know the location of the center of gravity of each part of the crane, and to calculate the cumulative center of gravity between the crane, the counterweight, and the load, and then to divide it up by the footing area, by the crane footprint. In the case of the crawler, you would have to know if the ground is like hard, if it's soft. The best way to get this is always go through the crane manufacturer. Every crane manufacturer now is making their ground bearing calculations available to the users. So there's no real excuse to just go and say, yeah, I'm just going to assume that the crane weighs, I don't know, 100 tons and the load weighs, I don't know how much tons, and I'll just multiply by a factor and I'm good to go. No, this is not the right way. It's just so wrong in many levels. It's not even a calculation in my view. It's just basically taking a wild guess and convincing yourself that it's, a calculation. I have news for you. It is not a calculation. Always go with the crane manufacturer software. I am a firm believer of that. If you have a Liebherr crane, you can always contact Liebherr. They will give you their software. Tadano DMAC, they will give you their software. Manitowoc, they have a beautiful, you can just go online and get their crane ground bearing pressure. Even now the Chinese cranes, who usually don't give, now they are starting to offer their ground bearing pressure because they understand that the user needs this information to get their permit. And also, guess what? Using manufacturer ground bearing pressure usually gives you less conservative results than by going with the rules of thumb. So for example, if I'm using a 200-ton crane, lifting a 10-ton item, if I use the formulas and calculations given by the client, I may have the maximum outrigger load of, let's say, 50 tons. But if you use the manufacturer ground bearing pressure calculations, usually it would come out to be about 60% or 70% of that value. And how that translates on the field is that you would have to use less mats to reduce the ground bearing pressure to meet the requirement of the client. Some software used to create lifting plans. Yeah, I would say it's very strange that companies are willing to pay, 20% of the total budget, even more, but at least 20% of their budget is on crane rentals and crane usage. However, they invest less than 1%, and in some cases less than 0.5% of their budget on the planning. The planning can save you. So if you invest a little bit more on the lifting plans, you would save your project a lot of money on crane rentals. Developing lifting plans using conventional tools like AutoCAD and relying on your draftsman. I'm sorry to say, I know maybe in the audience I have a lot of draftsmen here, but the draftsman alone cannot go through all the load charts of every single crane model to get the best result. It's humanly impossible. Even the lifting engineer cannot do that. Some of them, some tools are there, like specialized software, Crane B, Crane Planner, Lift Planner, whatever. They are all there. My favorite, obviously, is Crane B because, okay, I've been using the software for over 15 years, and I actually represent Cranimax, the developers of Crane B here. So for me, it's an excellent software, but as long as you use a software, I think that's the right way forward. At this day and age, it is always good to use software to plan your lifts. And then later on, you can draft it. What is happening now is that you are drafting what is in the mind of the draftsman. So he will draft whatever he understands or she understands. And then you will start doing your iterations. And we'll move the crane here a little bit, try to remove counterweight here, try to shift the crane there, reduce the radius here and there. That takes a lot of time. It's very laborious effort, and it's just no longer efficient. And with the growing number of requirements of lifting plans by the clients, I think it would be wise to at least consider using software to do your lifting plans and then to focus on your drafting as a final, at the final stage. Software will definitely save you time and reduce human error. Definitely. I do have some areas of concern about the condition of lifting plans. So in this market, in the Gulf region, unfortunately, contractors are limited by budget, and many contractors don't yet understand or appreciate the importance of lifting plans. So to think that the contractor will take the initiative in improving their process of doing lifting plans is, in my opinion, naive. The reality is, and it is a reality, quality of lifting plans is driven by the client. So, for example, if you go to a project in Doha, in the city, for a civil project, yes, lifting plans are important, but they are not as critical as, let's say, doing a lifting in oil and gas, because if a mistake happens in oil and gas, you drop a load, usually the result is really catastrophic. However, if a crane, let's say, falls in a civil project, like in the middle of an open road, okay, the crane falls over. Of course, we don't want that, but the catastrophe would be more limited than, let's say, when compared to oil and gas. Oil and gas would shut down the area, would shut down the plant many months. It will be disastrous. So that's why it is very normal to see, and even nuclear plants is even worse, is even more stringent. That's why I see a pattern where lifting plans are appreciated more by oil and gas companies when compared to civil contractors, civil project like highways. Even if they lift on a infrastructure project, like you're building a huge bridge, culverts, what have you, big foundations. Even if they're more critical and more difficult to do on a civil project, you would find that the requirement of getting the lifting plan in the detail of the lifting plan that goes in an oil and gas project will be more stringent than on the civil project. Why I say this is that because contractors normally will go as far as their client wants. So why so many lifting plans are poor quality? Because maybe the client is not requesting a good quality lifting plan. The client is happy with a poor quality lifting plan. So what's the incentive of the contractor to give a really nice lifting plan drawing? There's no incentive. If you can get away with poor quality lifting plan, contractors will go for the cheapest way, even if it does not save them money on the long run, but they would go for the cheapest method, which is to go with a conventional method, get a draftsman, get a AutoCAD drawing, and just go ahead with whatever you have. So it is a big area of concern for me that till today, lifting plan and the quality of lifting plan is mainly driven by the requirements of the client. And if the client is going to accept bad quality lifting plans, the client is going to get bad quality lifting plans. He's not going to get any more. Let's be real here. Here are some examples of, for example, bad quality. So for example, here, this crane is drawn like trapezoids and circles, and it's not even drawn to scale. This doesn't even look like a crane over here. So this is like a critical lift. I mean, you have 4 cranes lifting a pipe. So if this goes probably to a civil a civil project, it will get accepted because it has been accepted. However, when the same plan goes to oil and gas, not chances are, definitely it will not be approved. So, for example, this drawing, you see it, okay, I see a lot of lines. I understand what the draftsman is trying to say here, like, okay, this is where the crane is going to stand, but there's no real, in-depth check on, so this is a project I actually worked on, and this is a big crane, like a 300-ton crane. And what happened here was that this was sent to the client, and yeah, well, I don't want to say the client had approved it, but it was sent to the client. But when I went and checked the site on the field, I found there were pipes in the way, there were generators, there were foundations that were not mentioned here, because the draftsman didn't know that all these things existed here. So it's important that, now with the technology we have, I don't see any excuse why these mistakes should happen, why this miscommunication should still happen. So nobody is going to be able to draw what they don't see. So if the draftsman, and again, it's a draftsman, not a construction manager, it's a draftsman who is making the plan based on what they know, on the information that they have, you can't expect them to give you a proper plan, because if this one had been approved by the client, and they mobilize the crane and they send the crane to that position, and you find all these things sticking out of the ground, pipes, hoses, foundations, fire hoses, yeah, it would have been a disaster. It looks nice, but it's always good to have something more real. And that will be my next presentation, which I'll start in a few minutes. Excuse me. Here is an example of an incomplete, in my opinion, lifting plan, and they've been approved. I mean, this is, honestly, I would say it is scandalous. And this was approved in oil and gas project also. So you have here a pipe, okay, a pipe, no scale, isometric drawing, no scale on the crane, no scale drawing, and somehow it gets approved. And sometimes I see that Well, I had another example. I didn't want to share it because it's a project I'm currently working on. You know, the length of the slings was so long that there was no way it would have not. There was no way it would fit. There's no way that the crane had enough headroom to lift it. And thankfully, it was checked by the client, and they found out that they pointed it out. And at that point, they said, "Okay, we want scale drawings and nothing other than scale drawing." It's important to have a scale drawing. I mean, it's the only way you can know that your lifting plan is real or not. Otherwise, this is just a piece of drawing, you know, a schematic I could have done by hand. Here is another example of, I don't know how this got approved. I mean, you know, you don't even know what the shackles are. The slings are going sideways. This boom, this crane here is showing that, you know, it's being side loaded. Honestly, this shouldn't even be accepted. This is another oil and gas project, and somehow it was accepted. And I would definitely question the guys who are approving these drawings. I mean, are they qualified to review drawings? Chances are no. I mean, when I see this being approved, I know for a fact that whoever approved this is not qualified, even though they're client and, you know, they did the interviews and they have the certifications, whatever. There has to be a better way to I mean, they need more training, and there's got to be better ways to approve these plans. These getting approved, this is just scandalous. I mean, even look at the drawing here. Like, so this line here is showing 20 meters, and this here is showing 12 meters. To me, they look almost identical. I mean, I don't even need to scale these, but I know that the scale is definitely off, and that's 39 meters. I mean, this is completely wrong drawing, and it's sad to see that these are being approved. So I really don't understand who is reviewing these drawings. And this is the role actually of this is where I say, and I fault the main client, the clients who know that their role, they are the leaders in this. They are the ones who should be putting things in order, making sure that the drawings are correct, to have proper planning. Otherwise, you're going to be going back. We're just kidding ourselves. We're relying on the operators. We're relying on the site supervisor, you know, to improvise a lifting plan. And when this happens, you know, so at some point they're going to run out of luck and something's going to go wrong. The purpose of the lifting plan is to give yourself the chance to go through the drawing, to go through the lift, to assess the risks involved, and to avoid any mishaps later on at the time. There should be no surprises before the lifting takes place. And again, I go back to comparing the flight. So when you step on an airplane, you know exactly what time you're gonna get in, you know exactly what time the flight's gonna take off, and you know exactly what time you're gonna arrive. So this is all because pilots, they have a flight plan, there's a flight route, there are control measures, and I would feel very safe in that case. A lot of plane crashes happen when, you know, private planes, like when someone just takes off on his private jet, no proper planning, yes, they fall off. More of these there are more accidents with private jets than with a proper airline that does all the due diligence and the proper planning. So this concludes the lift planning part. I talked about the requirement to start to categorize the lifting plans. I will just go to the most important slide, which I prepared, which I recently prepared. And this one here, if this one is followed, I think everyone would be in better shape and better coordination. It may look like a laborious process, but I think we can learn from BIM and digital construction and apply it to lifting plans to improve the level of detail, to improve the data collection, and to improve the overall execution of the project. Having talked about BIM, I will now step into the next discussion, which is where are we heading next? And this is where I see the future of lifting plans, and I'm already getting into that. So as I mentioned before, we can learn from digital construction, which a lot of you may have encountered or not, but every project nowadays, so when I first started in this business, seeing a 3D model or digital twin, let's say, not exactly digital twin, but a recreation in 3D of the plant was seen as a luxury. Now, most clients understand that it's important to have a 3D model of the plant because it's better visualizing, for better coordination, for better execution of the project. And, like I said, we're human beings. It is in our nature to visualize things in 3D. So I will give you examples. So here's a software. This is actually from Crane B, my favorite software. So here what we did is an example. This is just an example. So I'm lifting a pipe over a building here. Basically, this building was scanned by a drone. And now, as you know, drones are very popular. And they're becoming cheaper and more efficient. So it is very easy now to scan the surroundings with a drone and to take the raw data of the drone and import it into software like Crane B. Even other softwares can import scans now, LiDAR scans. You can also do a laser scan. And then, so let's say you have an object, you don't have the drawing of it, you have a building. So either you take a drone and scan it, and the scans are, every year they're becoming more and more fancy, more and more accurate, cheaper, and faster. So imagine in 5 years where we're going to be heading. Now, the only thing that you can argue against this is that you can say, yes, well, what about the permits? Yes, it is not always easy to scan with a drone. You do need permits. It does have to be controlled, yes. However, I will give you the good news is that there are now rules in place on how to use drones and to get the permits for utilizing drones. Importing a 3D lifting plan straight into the 3D model can save us a lot of cost and time and money. So this was a very critical lift I prepared based on what the subcontractor was trying to do. So we were not sure if the crane was going to clash here. You see here, for example, the one with the crane in blue, you can see that the plant is very congested. It would have been very difficult to draw every pipe, every piece of structure, to gather all this information. So what we did was basically we drew the plan, superimpose the crane onto the 3D model, and checked it very quickly and found that there was no clashes actually. Same thing here. The client was making a big issue. Was the crane going to touch? Was it not going to touch the scaffold? Because even the scaffold was not easy to show on the drawing. Especially that when you consider cranes are not like flat objects. They rotate, they go at angles. So to do all that in 2D drawings is virtually impossible, man. Really, it's impossible. Always better do your lifting plan in 3D model, superimpose it on the surroundings, and you have your answer, and you'll see all the clashes or no clashes within seconds. And that saves a lot of time and money, and also gives a lot of confidence during the execution of the lift. So here's this is an actual case that I had. I did my lifting plan, put the 3D model. So the plot plan was only showing me a 2D, so I was just seeing basically lines. However, when I put it on the 3D model, I could see where the ditch was, see where the paving was. I could see this flushing skid, which I had no idea about on the drawing. Didn't really appear very clearly. So yeah, so before we went out and submitted this plan, I had the chance at least to ask the site to go and check. For example, this little stair here, that's on a structural drawing. There's no way I could see it on the plot plan layout. So they said, okay, we will go and remove the structure, this staircase before we bring the crane over, and also we will postpone doing this paving. And there was a ditch here, a cable trench. Also, they postponed all that because they realized that if we had put the crane in place, it would have damaged all the cables underneath. So this is a very good example of how venturing into the 3D model and using the 3D model with lifting plans can save the company a lot of money, can save all the stakeholders a lot of time and effort. And I totally advocate for this methodology. And I'll think it's only a matter of time before, if I were a client, I would demand all my lifting plans to be in 3D so I could check them on the 3D model and to see that there's absolutely no chance of any, let's say, clashes. And speaking about clashes, some software so CraneB again can import 3D models directly into the software and export into the 3D model directly. So you can import stuff, you can check directly, you can do your lifting plan without having to spend time drawing stuff. Very clear, very easy. All the charts are there, all the crane data is there, the ground bearing pressure is there, and you can start manipulating, you can move the crane in and out. Very fast, very simple. Rather than, this is the kind of level 2 planning I would call. So you do your plan before you get into the nuts and bolts of the detailed planning. Exporting to IFC, so you can export your lifting plan into other formats that the another end user can check for their, maybe the crane is in the wrong place for them. Maybe they know something I don't. So if I'm sending this to a electrical team, or maybe the permit, maybe this goes to the police, for example, maybe this is in a residential area, so you need the municipality to give you an approval. They have to see and they have to understand what is going on also. So I wouldn't expect the municipality to be able to read, 2D drawings, especially if they're not drawn correctly or properly or clearly. If they see this clearly, then maybe you get your permit faster because it's easier for them to understand. And yeah, now we can also leverage other tools. So you do your lifting plan in 3D, and then you can, let's say, export it to Navisworks, and Navisworks can automatically check for any clashes. So here's an example of a crane clashing with a beam. So I didn't have to redraw this structure to know that. I just take the crane, take the model, put it on a Navisworks, which is a 3D model, and the 3D model's job is to actually check for clashes. That's what 3D models are for, and that's a very strong case of 3D model being used correctly. Here is a live example of a project I'm working on currently. So we're checking the crane if it can fit in this area. What are the requirements? What are the holdups? So obviously here you can see a fence. This is a fence here. The trailer's going on top of a pipe, over a pipeline, and the crane is on the limit, and also it is stepping on other foundations. So to do a proper clash detection, you just add more steps. Again, this is using software. It becomes much easier than to draw all these different steps. That's why I always recommend use software for this kind of stuff. And then when you do that, you can actually check for use Navisworks to check the clashes. It will give you all the clashes. So to tell me, for example, this pipe needs to be put on hold. This little foundation here is in the way. This little other foundation is in the way. This light pole is going to be affected during swinging. This structure here is going to be on hold. Honestly, I mean, if anyone's going to tell me that the conventional way of doing lifting plans is going to pick all these clashes, I would say that's no way going to be the case. We have to start assuming stuff, or we have to do a lot of site visits, or we have to discover when the crane arrives. However, that's why I say it's always better to invest more time ahead of time, invest more time ahead of time, ask all the questions before, see the problems ahead of time, resolve them ahead of time, and then when you come to execute, you don't see any surprises, and everything should go smooth. So the crane will finish the job today, and then after 2 days, we'll go to the next job it's being planned for. So this is why I recommend a lot more strategic thinking when developing lifting plans, and to get out of the mentality or get out of the assumption that lifting plans are done in one go by the draftsman, by the supervisor. Yeah, we'll solve it, we'll resolve it. Because when you start doing the lifting plan, you will discover a lot of surprises, and there's a lot at stake while preparing your lifting operations. And lifting has in the past and is until today being a main factor in delaying jobs because of the surprises, because of not so good planning ahead of time. This is just a gimmick. Crane B, also we can export into 3D PDF, so you don't have to every time do a lifting plan and do all the views. You can just send it in 3D PDF, and every PDF now can rotate views in 3D. PDF, and my personal favorite now is Bluebeam Review. Anyone who's using Bluebeam or in engineering, I would recommend Bluebeam because it is tailored for engineers and construction. PDF does the job, but I mean, you can try both and you can see the difference and judge for yourselves. Thank you very much. This is the end of the presentation now. Any questions? Any questions you have? I'm open and I'll be happy to answer anything. Thank you very much.
Hi, Deepu. Are you going to be taking the questions?
Oh, yeah, Julia.
Excellent. There is one in Q&A as well as the chat.
Should I stop sharing now or I'll keep it?
Yeah, you can stop sharing. There is only one question to have.
Excuse me?
Yeah, we have one question from the member.
Okay.
Question is, what to be considered for daily lifting by overhead crane?
Overhead cranes. That's well, that's not really covered on this presentation because I'm talking more about mobile cranes and crawler cranes. Overhead cranes usually have a different set of rules, different, let's say, different, how to say, hazards than mobile cranes, and has a different. It's just a different operation altogether. They are both cranes, yes, but the inspection criteria, the hazards of overhead cranes are very different than those of mobile cranes. What is considered to be routine lift in mobile cranes? Again, that depends on the process, on the procedure you are following. So you have to check with your client or the law or the rules that you have to follow. So if you're in the US, there's OSHA, there's ASME, you follow. If you are in the plant in Qatar Gas, for example, you have to check the Qatar Gas procedure. If you are in ADNOC, you go and you check the ADNOC procedure. There, every client has their own set of rules for what is considered routine and what is considered critical. Does that answer the question?
Yeah. So we have one member who wish to ask some question. Yeah, Julie, is it possible to unmute him? Unmute Tony. Yeah. Hi, Tony. You can unmute yourself and you can.
Okay. Good presentation, Kamal. Really good. You know, the level of detail was really good, and the data section. I think it's so important on that data section to make sure that you've got the compatibility of the components used, because I've actually seen the wrong shackles used and it obviously result in a collapse. You know, I'm not sure how it fares in Saudi as it does in the UK, but upon winning a contract, the first thing the principal contractor normally does is looks for cost savings, and I think they all need to be made aware really of you know, whilst it's nice to make money on jobs and everything, your reputation is priceless, you know, so it's really important to make sure you do that. And I think the idea of like going out first prior to the commencement of works and doing a survey and checking on, you know, the environment, on, you know, what the floor surfaces are like, what you're going to be loading on, whether there's underground services, you know, segregation of members of the public and so on. I think it's also important to do that first, you know.
Yes, Mr. Tony, and that I would say would go into the first stage of preparing a lifting plan, which is gathering the information. So gathering information, it's a laborious process. It involves a lot of communication. Everything you've said, yes, you have to understand. You have to also know, I mean, what tools are available, what cranes are available, what slings and shackles are available, and who is going to be affected by the lifting operations. So do I follow the municipality laws, or do I have to follow oil and gas procedure? all this has to be done at a very early stage, so you know what you are up against. I mean, it's what you said exactly emphasizes my point. You have to ask all these questions at a very early stage, and it's also what you said. The lifting plans do affect other people.
It will do. You know, the thing is that I've seen people move barriers out of the way. I've seen them come under cranes to get to a cash point machine. I've seen so many things go on. You know, I haven't got nowhere near the experience you've got in lifting, but my 25 years of experience in the construction industry has come from seeing people do make mistakes, and that is the best experience I can get in making sure that anyone I'm working with doesn't make the same mistake.
Correct. But I would also like to add something. Mistakes in piping. Okay, no disrespect to the piping, but mistakes in lifting can lead to disaster. It's a very hazardous job. It's by nature, it's a hazardous. It's just hazardous by nature. That's why we need a lot of eyes on the same lifting, and that's why a lot of control measures have to be there in place. And that's why I compare it to the flights for airplane. Like now, despite the disasters that do happen, but airplanes are also always, you know, flying by plane is considered safer than, you know, crossing the road because of the control measures in place. However, whenever there's a plane disaster, the whole world knows about it because the cost of a plane disaster is a lot of lives, unfortunately. So the same, I mean, to a lesser extent, but the same philosophy I would apply to cranes and lifting, because any mistake. So if you make a mistake in painting, for example, I mean, okay, it's unfortunate. You'd have to take the paint off and redo it and stuff. There's probably cost, you know, a cost impact there. However, with cranes, I mean, there's life. Yeah.
Yeah. If you had a crane go over in a city centre or something, you would get TV coverage, but it won't be the right TV coverage you want.
Exactly. You're not going to be able to get also the people, whoever goes to hospital, how are you going to make all that up? I mean, there's a lot of compensation and a lot of stuff you cannot compensate.
Yeah.
Thank you.
No,
Thank you
very
for
good. Well done, Kamal.
Thank you. Thank you very much. I really do appreciate that comment. Yes, any more questions?
Yeah, we have one more question from Ian Gardner. What do you consider the highest risk to the operator if a poor lift plan has been approved, like you showed as samples?
What do I consider the operator to do?
The highest risk to the operator.
The highest risk to the operator?
Yeah.
Well, let me give you an example. Suppose there's a power line and it's dark, you know, and you'd ask the operator to go to a certain area and to perform a lift. The operator is not expected to survey everything. I mean, let's say it's dark and there's a live line, and this has not been picked up by the lifting plan or the lift planner. The lift planner has not gone to the site to identify this when they had this chance, let's say, to do so months ahead. Operator starts lifting, the boom touches the power line, and guess who pays the price? So unfortunately for the operator, they are the last line of defense, and any accident that does take place, you know, usually the first casualty is the operator. I'm sure you've seen many videos now on social media. You see a lot of videos of lifts going wrong. And many cases, if you look closely, you'll see the operator either escaping through the window, or unfortunately, they don't have time to escape, and the load falls on their cabin. So what is the risk on the operator? Yeah, the operator is a casualty. That's why it's important to take this responsibility and the thinking off the operator's chest, and make them feel comfortable that when they're lifting, that everything has been considered. So yeah, the risk on the operator is huge, and that's why I find a lot of operators get very, let's say, very agitated when they fear that a lift is is not correct, like something is wrong. And if the lifting plan is not there, they're gonna be very nervous. And this operator has to be very nervous, perform a critical, job. And, I just can't imagine the amount of pressure they're put under.
We have few more questions in the chat box.
Yep.
If operator have 500 T competency training, they can operate the more or less capacity crane.
Sorry, can you repeat?
Yeah, the operator have 500 T competency training. They
Okay.
can operate the more or less capacity crane.
Okay, this is beyond the subject, so I'm not really involved with the qualifying crane operators. However, I will tell you this: in the project that I'm on now, each third-party certificate is mandatory that the third-party certificate specify the exact crane model number that the operator is allowed to operate on. So, for example, the operator has 20 years of experience, and you give him a groove crane. If he's not familiar with the buttons and the layout of the controls on the groove, and he's used to, let's say, a Tadano or a lever, then yes, that can cause a problem. It's not about how heavy the crane is that the operator is operating. It also has to be, he has to also be familiar with the crane itself. And personally, I agree with this rule, although I find it's very over the top and very shocking to the third-party certificates giving to the crane operators. However, again, it's always good to look at other industries. You've all heard about this Boeing, what is it, 888, is it? Sorry, the one with this control that just kept pushing the plane down. There's a button, the switch that they forgot to turn off, or this new crash in India, the pilot forgot to turn the engine thruster off or something. So sometimes if you're not familiar with the equipment that you're operating, I would say the result can also be just as bad as getting a novice to fly to operate a new item. So I think the more control measures you do, okay, they are inconvenient. However, if a contractor or the user of the crane knows how to understand that these are new requirements, and these requirements are going to cost them extra money, then this whoever's doing the job has to include that in their initial estimate. Money aside, I am all for better controls, because now you're getting cranes from China, you're getting cranes from all over the place. Some Chinese cranes, they come with operating manual in Chinese, for example. Some of them do, at least. So do you mean to tell me that if you operated a lever, a 500-ton lever, you can go and operate a 250-ton Sani crane, for example? In my opinion, it's no. I think every crane has its, every crane is unique, and every operator should be familiar with every familiar crane.
Yeah, so we have, I will merge two questions together, like both are regarding lifting plan.
Yeah.
Everything be planned, even the smallest lifting that happens in the site, with plans and drawing. Or can we avoid it with the risk assessment? Like every lift has to be planned, even the small
lift be planned, even those non-critical on site. Again. So if you go to, you have to check with your client what is deemed as necessary for lifting plans. As I said, the requirement of lifting plan is driven by clients. So it's very rare to come and find like a contractor's, when a client says, I want lifting plan for everything above 50 ton. I don't think it's going to be very common to come and find a contractor is going to come and say, you know what, I'm going to do lifting plans for everything above 10 tons because that's my safety policy. If that were the case, great. But that is not the case as of today, especially now that we are living in a, the projects are becoming more and more budget tight. So yeah, the quick answer is, yeah, you need, I think now we need more lifting plans, because in all honesty, I think that the level of supervisors has gone down for whatever reason. or the level of a lot of novice people in the site. It's a growing industry. So yeah, we need more control measures, and it's just up to the lawmakers or whoever's in charge of the rules to come up with what is deemed as requiring a lifting plans or not. Personally, in my assessment, I even sometimes require more lifting plans than what the client requires, because in my nature, I like to see more lifting plans being done, and I don't like surprises. I don't like last minute surprises, and I don't want the supervisor to come up and improvise at the last minute while standing and under pressure. I know I did not answer the question correctly, but in my view, it is a gray area, and this is something that needs to be discussed with the client.
Yeah. Hi, Julie, can you ask something?
Excuse me?
Yeah, I'm asking Judy to allow Cedric. Certainly, he like to ask something. Yeah, Cedric, you can unmute yourself.
Go ahead.
Dipo.
Yeah,
Hi, Dipo.
go ahead.
No? Is my voice is clear?
Yeah, it's clear.
Okay. Thank you for the great presentation. It's I appreciate on this. Yeah. So I have one question. So I get one sample on the on the presentations, and they mention here is they mention here is maximum radius, right? But supposed to be, they will mention a pickup radius and the placing radius, right?
Yes.
Yeah, because they made one of the sample that I have is in my I captured in your main crane data is they are mentioning here is only maximum radius.
Yes. So yeah, that's for the crane lift. That's to make sure that the crane can lift the load. Sometimes your limit is the minimum radius also. In some cases.
Yeah, because this is the one way I implement on site that I need to see where is the pickup radius, which is R1, and R2 is the placing radius. Because if I don't know this one, if the contractor not able to show me what is the pickup radius and the placing radius, how you can compute your calculation?
Again, it depends. So the purpose of you're talking about the chart, the table, is that correct? The table.
Yes.
Yeah, on the table, normally on the table, we show that the crane, the purpose of the table is to show that the crane is capable of doing the job. So if a crane is going to pick up, let's say, a 10-meter radius, then boom down to 12 meters, and then swing at 16 meters, and then put the load at 20 meters, and you want the contractor to put all these, different tables, okay, you can, but it's a lot of work. In my view, the purpose is to show that the crane can do the job. So the worst case scenario is the maximum radius always, because that's the way it is. However, it's also important to note that the minimum radius, I think, is also sometimes missed. So sometimes, a lifting plan shows a radius of 4 meters, and the minimum radius is like 6 meters at a very long boom, for example. So, and that's why, so if you go to software, for example, like Crane B or other software, they would automatically just print out every radius of every step, and you get like a big document of maybe 20 sheets for every single step. Yeah, you can do that automatically. Again, it depends on what the client wants to see, and why they want to see it. So I personally, I don't know, I would like to minimize the amount of, to give enough information, not to overkill it, but to give enough information. So if I want to, just to be sure that the crane can do the job, that when it's lifting at 20 meters, which is the maximum radius means normally highest ground bearing pressure. Normally, I said, not always. And always it will have the maximum, the lowest capacity. So That's my answer to this question. Now, sometimes also you may wonder, okay, if you're doing a tandem lift, let's say the crane is picking and he starts off with a long radius, but the load is like a tandem lift. So the main crane would pick up, let's say, a load at half the weight, let's say, and by the time he's booming up or reducing the radius, he's carrying more load. Then in that case, yes, the load is changing, the radius is changing. You need to know at every stage what is the capacity. But if the load is the same and the radius is changing, personally, I think it's just enough to show the maximum capacity of the crane and to be sure that the minimum radius is not that you're not lifting below the minimum radius, because that can also create problems.
You're right. Yeah, you're right. Thank you. Thank you. One last thing for me. One of the third party. I will not mention the name of the third party company in Qatar. One of my challenges is I found last week, and I have a conversation with one of the third party company. The third party company, they do for the third party.
Very nice. No. Yeah. I just came spontaneous.
Hello.
I can't hear. Can you please mute?
Hello. I'm
Yes?
clear. I'm clear,
Yes,
Tipo.
yes, I can hear now.
Okay. Now, one is my struggle is one of the third party company in Qatar. They do a third party inspections of the one of the crane, and after the third party inspection, this is normal that they give this ones the orange copy, right? It's the third copy or the second copy of the third party inspections, and the third party allow the contractor to proceed the lift, even they are using this one's a ticket during the inspections. So, are you agree on that?
I'm sorry, I didn't understand the issue. So you have a third party inspection and he give you what, a sticker or a third?
No,
or
they give this one the ticket. The third copy of the inspections, the receipt.
okay.
Right? And they allow the contractor to start the lift, and they explain the contract that the ticket is equivalent for the third party certificate, which is not approved, which is I never allow to lift.
Oh, so you're saying they're giving like a ticket instead of the certificate? Is that because your voice
Yes.
broke up?
I think he's talking about the
Yes.
time copy. When the
Yeah.
inspectors visit the site, they used to carry a book with them, the timesheet book, where they used to record
You're right.
inspection details. So I believe Mr. Cedric saying that
Yeah.
the third party company who visit his site, they have been giving the copy of that paper saying that they have inspected. And on the side, they are moving forward with the usage of that crane by using this paper. That's right, Cedric, right?
You're right. Yeah, you're right.
Okay, you're talking about fraud over here. If I understand correctly, you're basically giving someone like a open ticket to a signed document that I've checked the site and they were not there. Is this what I understand?
Actually, the normal practice which I have seen is when the inspector visits the site, they used to give a proof of inspection. That is the timesheet copy. Once the inspector reaches back office, only they will start to print the certificate. That is a common practice in most of the location. Because on site, when the inspector is there, he can't print the certificate immediately over there.
Oh,
Or
yes,
else or else they have to go through digitalization. That is the only way they can print the certificate immediately. So this is a current practice which I have also seen. But I believe the question over here is how long they are taking to issue the certificate.
Yeah, okay, this is about certification. So
This is about certificate. So this is completely a big topic actually. I will say it depends upon the project-based requirement, the call which you guys are going to take, whether you need to go forward with the inspection by trusting the timesheet or whether you have to wait for the certificate copy. But legally,
our requirement is we need a third-party certificate. That the timesheet, we cannot say this one is the third-party certificate.
Exactly. That is just a proof of inspection. Yes.
Yes. That's all for me. Yeah, thank you very much.
I would say my only recommendation is if it's like an inspection every 6 months, just do the inspection earlier. And that's what I tell. Like I'm on a project now, and I have a PMV, and I insist on the PMV to start inspecting the crane if the requirement is every 6 months. 3 weeks before the crane expires, do the inspection. I mean, and that way we have it ready, in time.
Yeah, so I believe that's it. Yeah. Oliver has asked a question, same regarding lifting plan. Can we override lifting plan with JSA method statement? Is it enough?
Again, I mean, this goes back to what your client requires. The rules, the rules are set by the client. But I've seen projects like I've been on a stadium where some very scary lifts of weird shaped structures, were done by a guy just writing down notes and saying, okay, this is what we're gonna do. We're gonna take this thing, we're gonna wrap it around many times on the beam. We're gonna lift it at I don't know, 12-meter radius. No visualization, no visuals whatsoever. I don't consider that to be a lifting plan. Urgency, I mean, look, I know some jobs are urgent, some jobs are easy. And this goes down to what your client requests, routine lifts or non-routine or critical or very routine or whatever. However, I would say when this stuff happens, it's an indication that the planning is not there. Okay, so there's a gap in. So when that happens to me, I wouldn't blame the system. I would look at myself in the mirror and say, how can I improve on this? Why am I doing these last minute changes? Why am I doing these last minute changes? Have I been informed late? Has someone else not informed me in time? If other people who request the lifting plans don't understand the process, maybe I should give a workshop and make them understand how much time it takes, because it's not easy to do a lifting plan. It takes time, and the approval cycle takes time. And why should a client even take the risk of having a job, unplanned job, take place at his job site? I mean, you also got to think about your client. If your client put a set of rules for you to follow, and you just jump on the site and say, "Hey, this is not what we did 20 years ago," well, I'm sorry, but that's not the client's problem. That's your problem, because you sign a contract, you have a new procedure to follow, and you should spend time to memorize this procedure, to understand it by heart. I mean, these things do happen, and once I was a client and I did that, and so there was a tandem lift that was supposed to take place. They were offloading a vessel. I'll go through this very, very quickly. The story that happened to me. I was busy at the gate to bring a vessel in, and we only had to offload it. All right. The plan was to offload it using 2 cranes. And funny enough, we didn't even need a lifting plan for that. Funny enough. Now, multi-crane lift, every multi-crane lift that I know of needs a lifting plan. But in that case, anyway, long story short, I arrived at this location. 1 crane had been demobilized, had been sent somewhere else, and the client and the subcontractor told me, well, you know what? I have this 200-ton crane. He can offload it. I said, but how? The thing weighs like 50 tons. He said, don't worry, just stand behind the barricade, watch me do it. And I was too soft, and I said, yeah, you know what? It's an urgent job. It's the weekend. Even me, I had a flight to catch that same day. I said, okay, go ahead, do it. You've been doing lifts, you've done already 50 lifts that I can count on this project. Just go ahead and offload the thing and, forget that anything happened. As soon as he put the slings on, I was like, wait a minute, what's going on? He's putting he doesn't have the right slings. He doesn't have a spreader beam. Okay. So he tried to improvise with slings. As soon as he started lifting the vessel, it started tilting and it fell on the trailer. All right. And the feeling I had was that the thoughts that went through my head. First of all, I said, I'm gonna see a crane fall down for the first time. It was overloaded. The crane was like on 90%. an equipment just fell on top of a trailer, for crying out loud. And why? Because somebody on the project decided that they don't need a crane, that they can do it on their own. And they convinced me not to worry. So I felt very stupid and duped. And from that day on, I asked myself, what am I doing to myself? Because this was my responsibility. This thing, it fell on a trailer. It could have fallen on someone and killed someone, right? So the only reason we had to go through all of that was because somebody did not plan their job very well. Somebody decided to take a shortcut. Someone decided was too arrogant to say, you know what, let's plan this. And you know, the subcontractor didn't have the right rigging tools at the time because they weren't too bothered to plan their work. And I felt very bad. Like really, I felt very bad that I felt at that time, I don't deserve even to be on this job. I don't even deserve to be here. I am not the right person for this job. I was lucky that the safety manager, because rigging was under safety at the time, was kind enough, let's say, to let me off the hook. But he told me, I mean, Kamal, yani, really, I don't know what to say. I was like, yes, I don't know what to say either. It was a mistake. It was my mistake. Even though I was not doing the job, I'm not the one who did all the mess, but it was my responsibility. So when your client tells you, no, I want you to follow the procedure, you need to also understand from their perspective what they're up against also. Because if something goes wrong, you know, their reputation's on stake, people get hurt, people get killed, and if you keep letting this go on, you know, okay, today it's urgent, tomorrow I have one urgent job, the next day it's going to be like 5 urgent jobs. Things can go loose very, very easy. And so yeah, I'm personally, I'm a procedure person. I like to stick to procedure. If I have to do more work, if I have to plan my work earlier, yeah, so be it. I have to, you know, that's what we have to do. Now, did I answer the question?
Yeah. Thank you, Kamal. Thanks a lot. So I believe we have gone beyond the time actually, and I really appreciate the participants waiting over here. And I believe our chair also has been joined. Hi, Rock.
Hi, how are you? It was very interesting. I was hearing everything.
Yeah. So we are
Sorry
at the end
for
of
not being there.
yes.
Yeah.
No, but Kamal did a wonderful job with the confidence and his own storytelling and everything. I really appreciate, and I'm sure everybody liked it also.
Yeah, it's a really wonderful session, Kamal. Thanks a lot. Thanks for taking this opportunity and giving us.
Thanks to Deepu. Thanks Deepu to you also, and thanks to Jugi and everybody, and especially the participants for being there. And we have got a lot of good plans for you ahead. Okay.
Yes. Yeah. So good night to all. Good night, Rock. Good night, Kamal.
Good night.
Thank you.
Good night.